Good morning once again. A very warm welcome to each one of you. And thank you for joining us today for building AI applications with MongoDB, right? And MongoDB Atlas Vector Search, which is our main topic for today. Uh, it's great to have students, right? And anyone who wants to explore this concept, whether it is developers, technology enthusiasts, right? Even I think faculty members have joined us, which is wonderful, right? And working professionals who are with us. So, before I introduce our guest, right, I'll tell a little bit more about what uh, today's session will be, right? So today's session will take us beyond, right, the basics of AI, right, and into one of the key technologies enabling modern intelligent and applications, right, which is very important in today's time, and that is vector search. And specifically today's topic, which is MongoDB Atlas Vector Search, right? We'll explore how applications can retrieve relevant information, understand context, and deliver more intelligent results along with practical use cases and implementation insights. So, my name is Yatharth Sharawat, and I'm from SmartBridge, and I'll be your host for today's session. Right? We are excited to have an industry expert like Darshan Jayarama with us. So, welcome, Mr. Darshan. Right? And I'm sure this session to each one of you, it will offer valuable insights, and you can apply your own AI and development journey, right? With all the insights that you will learn today from Mr. Darshan's session, right? So before we begin, I'd encourage everyone to stay engaged throughout the session. That is the most uh, like priority. That would be the priority of the session. That please be engaged because we have to make it a little bit interactive as well. And if you have any questions or anything, please drop them in the chat. We have an interactive Q&A session, which would be taken care by Mr. Ajay, right, from SmartBridge towards the end. And towards the end also, there is a Q&A session, which I think Mr. Darshan would be taking care along with us. So make sure you stay with us till the end, uh, right? And I'll just quickly just let me just yeah. So I'll just quickly tell about SmartBridge as well. But before that, let's just go back to the slide. Are you guys excited? Can I get some fire emojis? Okay, somebody's laughing. Cool. Right. I need that fire emoji, that lit emoji. Nobody, I think Zoom does not have lit emoji option. Understandable. Yeah. So I think many are excited. Yeah, I think that's good. So I'll just quickly tell you about our organization as well before we start and before Mr. Darshan takes over. Right. So like about SmartBridge, so we are an 11-year-old company, uh, and like it was we were founded in 2015, and we are AI first skilling ecosystem and talent accelerator. And SmartBridge like focuses on building a future-ready workforce by connecting academia, industry, policymakers, right? Through industry-led training and virtual internships, global certification programs, hands-on experiential learning, right? And career-focused and career-driven skilling initiatives. So SmartBridge learners help like and build practical skills in emerging technologies, right? Including a lot of you would know artificial intelligence, generative AI, Salesforce, ServiceNow, cloud computing, cybersecurity, data science, IoT, robotics, and of course MongoDB as well, and more. So our goal is to bridge the gap between academia, right, and industry, So we bridge the gap between learning and industry if you want to get to the crux of it. So by helping learners build skills that translate into real career opportunities, and you actually get things done, right? And you are uh, day one ready in whatever you do, right? So yeah, so that's one thing. And before I so this was all about our organization, SmartBridge, right? And many of you already know about us, but this was something which a lot of you won't be knowing. So yeah, so I'll just introduce our guest for today once again, but in a brief manner. Okay, so first of all, like we in SmartBridge, we are delighted to welcome Darshan Jayarama, who is MongoDB developer champion and MongoDB engineer at Champ Cargosystems. So, Mr. Darshan brings 13 years of experience in database engineering and has previously worked as senior technical services engineer at MongoDB itself, right? So, along with technical roles at Python, Hewlett Packard, and Altisource. He has delivered numerous technical sessions. Like a lot of you who have joined today already have met him at a lot of MongoDB events, right? So he has delivered, numerous technical sessions on MongoDB AI, vector search, right, and modern data architectures, and is, I should say, very passionate about simplifying complex technologies and empowering the next generation of developers. So that's his mission. And in today's session, Darshan will walk us through or take us through MongoDB Atlas Vector Search, how it enables intelligent and context-aware AI applications, and how these technologies are being applied in real-world scenario and use cases, of course. And I'm sure this is going to be an insightful and highly practical session. So, without further delay, let's get started. So, Mr. Darshan, over to you. I'll just
Yeah, sure.
stop sharing my screen if that's correct, huh?
Yeah.
I'll just stop sharing. Over to you,
Okay.
Mr. Darshan.
Yeah. Thanks, Siddharth, for giving a brief about myself that reduced one slide of my explanation. So, good morning, everyone who are here today virtually, and I can see the enthusiasm in the chat box of all of the students and all the attendees. Um, and it's totally, like I can understand like how much excited you are for today's session in order to learn something new. I understand like it's a Saturday, and I usually start or spend my Saturday by watching some movies in the any OTT platform, or and in order to select like which movie I should watch today. So that depends on like how or like what kind of movie, like maybe it's a comedy movie, or is it like a thriller or a suspense, or like so on. And finding the exact movie in order to the mood that I am currently in, like that is very much challenging, right? Like we might not able to get an exact movie that we wanted to spend. So what we'll be doing, we usually do like maybe go to Google, or maybe like Rotten Tomatoes, or any of the IMDb, any of these kind of website. So there we will be maybe searching something like an context, right? Like something like a suspense thriller movie in Kannada, or horror movie in Hindi, or like based on that, right? So that is how we will be finding the movies. So back of the this particular query, there will be lot of many things that will be running, and at the end it will be giving us the results. So what are those things that runs in the back end? That's what we will be discussing today. Okay. So hello everyone, myself Darshan Jayarama, and today we will be talking about building an AI application with MongoDB Vector Search. So I have over 13 years of experience in the database industry. I started as MySQL, MongoDB, Sybase, and Progress database administration. So and I worked in a company called Altisource back then, and then I joined HP, and then I joined Python. And previously I was working at MongoDB, and currently I'm a MongoDB engineer at Champ Cargosystems. So it's a European-based cargo company. They are completely into aviation. And yeah, so I am also MongoDB community champion. So it's an recognition from the MongoDB, because I do conduct this kind of seminars, and I write blogs and like a lot of community contribution. So based on that, like they will be selecting worldwide certain engineers or certain professionals who will be contributing to the community. And yeah, so I got an opportunity to speak at the Bangalore MongoDB local. So it's an yearly once event that will be happen. And I lead MongoDB user group for Bangalore region. And I have wrote more than 10 plus blogs that published from the official MongoDB channel itself. So this is about myself and my interest and passions about the MongoDB. So you can see all of the lines is containing about MongoDB except my education, right? So yeah, so without further delay, we can maybe jump into today's topic. So we can keep this session as very much interactive. If you guys have any questions, you can feel free to post, put them in the chat box, or maybe at the we can address them at the end of the session, because there are a lot of attendees in this seminar. So if we are addressing each one at the in the middle of the seminar, like it might take us to the away from the actual topic that we wanted to discuss here. Okay. So what we'll be doing in the regular day-to-day database search queries, right? So we will be using the exact keyword matching mechanism. What it will be happen is, when you search for certain pattern, right? So it will be finding those records that has an exact meaning or the exact match for that particular word that you will be finding with. For example, take an example of bank account number, right? So when you are entering the bank account number, it should return the exact match. It should not return any of the closest match or the nearest match, because that completely changes the actual security, or completely the changes the actual application needs overall. So that is how the actual exact keyword matching pattern mechanism works. And when we are searching for like you assume, like in the Amazon in the previous days or the older days, when it was launched back in 2010 2012, that time, when you are searching for certain words like running shoes in the Amazon, what it would be doing is, like it would be searching in the shoes sections only. Like it might not would have given you maybe alternative gears like t-shirts, or maybe like quick dry shorts or something like that. So it would have not given alternative, because okay, so if the particular person is searching for the running shoe, he might be also interested in the quick dry or quick fit t-shirts, or maybe like a smartwatch, or maybe any other extra gear that can help his running journey or something like that. So it would have given only the exact keyword match. So that is the limitations back then, when if the keyword that you are searching is not matching with the database entry, it would have not given any results. Like it would have shown like no results found page back then. Okay. So in order to solve this problem, right, because human language is messy, right? Like if I will be using certain words may not be used by some of you, right? Like it may be you will be using the different word, even if we are talking in the English also. Some may say it as a shoe, some may say it as the sneakers, or some may say it as like maybe different words for that perfume and scent, like that. So we will be using different keyword. So human language is very much messy, right? So think about like a scary alien show example here, like that's what we are trying to show in the image as well. So if I type like a scary alien show into the database, it will search only the index, the title with the that matches with the overall context, right? Like maybe Stranger Things. It will might not be able to show that. So the keyword search will treats the alien and this extraterritorial as a two completely different unrelated things, right? So this is a fundamental gap. So here we will be not able to give, or like as a user I will be not know like what exactly the keyword that the database is having. So if I know, then I can able to read that. So we might not able to create, or we might not able to build an application that is general purpose, right? So if it is an internal organization, like let's say a banking application, so we will be able to use the exact keywords, because we will be having the dictionary, and we will be or we will be having the for this particular keyword you should search only with this particular these are the keywords that you should search with. So we will be having then internal comparison or the dictionary kind of book, so that like we will be able to use those application. But in order to build an general purpose application, right, like something like an Amazon, something like a Netflix, something like an maybe like a quick commerce application or anything, right? So in those cases we will be facing a huge massive gap here, because the user will not know the exact word or the keyword that he will be searching for. So in order to resolve this, we come up with a semantic search term. Okay. So semantic search is something, in the modern application, it works like a magic, because the apple, if I say apple, so there may be people will be thinking I'm talking about the fruit. But if I was talking in this particular seminar and I mention apple, apple is a great example, right? So if I mention this particular code, you will be definitely understand that okay, I am talking about the computer or the company that makes the computer or makes the phone, something like that, because it's because we are in the technology seminar. And when I am talking about the apple, you will be directly correlating your thinking to the technical terms, right? So you will be not thinking about something like a fruits or any other different aspects, because this is how the context that comes into the picture. So semantic search is something like a shift from looking for the word to the understanding your overall intent, right? So instead of filtering row based character matches, right, like the one to one character that you will be matching, what we will be doing is semantic search will be evaluating the concept behind your query. And for example, like when ChatGPT gives you an something like an elaborated answer, it not looking for the dictionary, right? Like it will be finding the semantic search. Like when you given any of the query, like maybe if we have to go in the very complex word, and let's say I wanted to file an income tax return, so I will be mentioning my form 16 or any of those terms to the chat gpt, like okay, so where I can save the my very income tax in the obviously in the legal way. So it will be giving me like where and all I can show, or where I should invest, or I should diversify my income, so that I will be having the less income tax to be paid and that gets the maximum return, right? So here we I am not asking it like, should I invest in this particular scheme so that I will be getting the less income tax. I'm not giving that. I'm just mentioning that, okay, I want to save the maximum income tax that I will be paying. So based on that, it will be understanding my intent, and it will be understanding my income, and where I can invest how much, right? Because let's say if my income is 100 rupees, I should not, or I cannot invest 80 rupees or 90 rupees or some huge amount in the certain scheme, because it should also evaluate, if I invest or take out this particular amount of money, he should also do his livelihood with the remaining money as well. So it should think in those many aspects as well. Like, this is going like pretty much beyond the concept, but the overall semantic will be happening. All these aspect it will be comparing, like all these aspects, like it will compare, and then it will be giving us the overall outcome that what we will be searching for. So here in this particular example also, you can see that we will be searching in the chat GPT, and it will be giving us the answers based on the exact, not exactly the exact word, but based on the meaning of the word that you will be searching for. I hope everybody in this room have used the ChatGPT, and I don't have to give an explanation about how how the ChatGPT UI looks like and what you will be getting an answer in the overall terms, right? Okay, great. So when we are not using the exact word, what we will be using, or how the database will be evaluating your query, right? So that is the fundamental question, that how the database or the application will be retrieving the results from the databases, right? If it is an query, then it will be found in the regular index that you have created, and it will be do the one-to-one key, like the character matches. It finds the results, fetch the document, and gives you the fields that you have requested for. Okay, so that is completely fine. But when it comes to the semantic search, it cannot use that, because it should be based on the context, or it should be based on the meaning, not just based on the exact word that you will be searching for, right? So in order to do that, we use a technology called embeddings. Okay, so that's what we call it as a vector embedding. Okay, so think of this as a translation layer, right? So when we say certain words, like even how we will be interacting with the computer is with the help of like a keyboard, or with the help of a mouse, or with the help of like a trackpad. So whatever the action that we will be putting on the keyboard or mouse or trackpad, it will be converting them into the binary words, right? Like, let's say if I press the keyword arrow key, right arrow key, the next slides comes up, right? So the what will happen is, when I press the arrow key, it will be sending a signal to the CPU. The CPU will be understanding the signal based on the driver that you have installed. The keyboard will be having the keyboard driver, right? So it will cross verify what is this particular signal means for. So that gives an complete explanation about like 100 binary code, whatever the key that you have pressed. So that key, that the number will be having an exact action that the CPU has to perform, right? So same way, when I press the right arrow, so it will find the binary code, and that binary code will be having an action for this, maybe like this particular web page, right? If it is in the this particular web page, it should show the next slide. So that is how the overall action and the reaction will be working. The same way, when I pass certain like for example, the same word that we have used, the messy word, right? Like the language is, human language is very much messy, right? So when I search for something like a Paris, okay, so it will not just show the Paris, like, but it will relate it into the France as well, because the Paris resides inside the France. Okay, so this this is how we will be getting the vector embedding. It is a huge number of an array of the huge number. So I will be showing like how it will be looks in the maybe next slide. So it is not a random number. So how these numbers are generated is it is the coordinates in the multi-dimensional array. Okay, multi-dimensional maps. Okay, so this is how the word dog will be looks like. Okay, so you can see like a 0.12 minus 0.14 sorry 45 and 0.88 like that. So there will be a huge number of array element that you will be seeing, right? Like you can in the for the word dog you will be having huge number of embedding. Okay, so what are these numbers are? So these are the floating numbers in the multi-dimensional array. Okay, how we will be defining the multi-dimensional array is like think of like a two-dimensional x-axis and a y-axis, right? For example, for the better example, it is the map, right? So in the map, what we will be passing is the latitude and the longitude, right? So the latitude gives you the x-axis and the longitude will be giving you the y-axis. So based on that, anybody can locate where exactly you are in that particular maps, right? Because the latitude and longitude will be plus or minus like 2 to 3 meters that you will be away from. Even while you sending the live location in the WhatsApp or something, you can easily see how much the plus or minus location that it will be having. Like there will be a round, it will be showing like a 3 meters, 10 meters, 15 meter, 20 meter like that. So based on that, like it will be sending the overall exact location. But if it is less than 5 meter, it is pretty much okay that you will be you can easily find that particular location. But actual latitude and longitude can give you the overall exact location where you are standing from. Okay, so that is a two dimension. And when it comes to like which floor I am standing, so that need a longitude altitude as well, right? Like from the ground, how much far or the how much height I am standing from. So based on that, like that becomes a three dimension: latitude, longitude, and then the altitude. And exactly in that particular floor, in which direction I am seeing, right? Like let's say there may be in this exact location itself, there are 10 people surrounding like around in the basis, like we might be standing, right? So in that particular direction, let's say I am exactly to the southwest side of the this particular latitude, longitude, and then the altitude. So based on that, like you can maybe find 2 to 3 people, like because the southwest is still can be there may be, if the 10 people are standing, like you can still find a 2 to 3 people. And then you will be finding like maybe, okay, I'm wearing the black t-shirt, right? So based on that, like you will be exactly pinpoint who the person is. So as we will be giving you the more and more context or more and more vector or the more and more data about the particular person, right? So you will be able to find the exact person who is located where. Okay, so this is how you will be finding a particular person based on the data, different aspect data you will be validate, and you will be able to find that person. The same way, when I pass the word called dog, it will be converting that into the this particular embedding. So how it will be converting? Okay, dog is an animal, right? So it will be makes the one coordinate as related to the animal, and next it will be having a tail, and it will be having it can make a sound, and it's a domestic animal, and it's has different breeds in it, like that. So it will be having all the details that are related to the dog. Okay, so how this will matter in terms of in terms of your query is that it matters because we are not finding any particular term based on the world, right? What we will be doing is like we will be searching show me the domestic animal which makes large noise. Okay, so if I do that, it will not show the cow, right? The cow yeah, can make a noise, but it is not an aggressive as well, right? It can also show, it cannot show the like maybe domestic animal is a pig, also is a domestic animal, but it will not make noise, right? So based on that, it will compare and it will be finally giving us the results. Okay, so the vector embeddings are the individual characteristics of the object, and the same characteristics can be matched with the other elements, or sorry, other elements as well, like not exactly the elements, like maybe the objects as well, but the overall objects element is combining with the all of the features, depending on the how much embeddings that you will be using. Okay, so these embedding will be marked in the high dimensional spaces. So I believe like you might have understood like how high high dimensional will be imagined like. So here you can see there is a like a x-axis, y-axis, and a z-axis is a three dimension, like you might have understood. Like there will be a fourth dimension that we will be 4, 5, 6, 7, like that. So there will be a huge dimensions that you can think of. And by default, MongoDB uses like from the 256 till the 8198 dimension. So in this particular example, like they are using the 1536 dimension. Okay, so you can see the dog and a puppy is closely located, and even the pet is also pretty much close comparing to the internet or the computer, or any other word that is shown in this particular example, right? So in the high dimension, it's mapping the concepts related to the dog and a puppy that are close together, and it will be not showing any of the unrelated objects in the pretty much nearest. Okay, so in order to so far we were discussing about the vector embeddings, and based on the vector embedding we will be finding the particular object, and we will be able to use that in our application or anything as such, right? So how it will be generate, or how anyone can generate the vector embedding, is that we will be using something called a encoding mechanism. Okay, those vector embeddings are from the encoding, like a transformer encoding. Okay, so if it is a text, then we will be using certain models, like an LLM model, something like an text to embedding models, right? So when we pass certain keywords or certain terms to the encoding model, it will generates, or because these models have been trained with the billions of tokens. Okay, so based on the word that you will be passing, so it will be predicting the related like the feature of that particular word into an embedding, vector embedding, like an array of embeddings, and that will be given out from the as an output from the transcoder encoding model. Okay, so assume like you are building an application or writing a code using the Copilot. Okay, so the Copilot, if you give like a like let's say define def add function, okay, add underscore function, and then open and close, like if it is a py file, so what it will be doing is like it will be writing the remaining line of the code, right? Sum is equal to a plus b and return sum. So this is the overall code that it will write. So how it will be writing that code? By just reading the function name itself, right? So that will understand the overall context, and okay, so that particular file name is a calculator.py, and you are writing a function for the sum dot add function, and for the add function you need two variables, two numbers that you will be having. So assume like a is the first number and the b is the second number, and sum is the summation of a and b, and we should return the sum. So this is the overall concept that it will understand, and it will write all those functions, all those line of the code, and complete it for you. So that is how the Copilot will be working, because the Copilot model has been trained for the completely for the programming or coding related background. right? So you cannot maybe use the same coding, like um, for the coding trained model, you can use, but you will be not getting an exact or the better results for the maybe like a financial stock analysis or any other unrelated different completely different model as well. It's something like, okay, I have studied engineering, and if somebody comes to me and ask about like what is a treatment for this particular disease, I may not able to answer it. If I have studied, if I have completely trained on that, I will be able to answer that. And whatever I will be giving, like it will be based on maybe my previous experience, or maybe like I can do like, okay, so if I'm too much headache, like I will say like, okay, I have taken this particular tablet, like you can also take like that. So that may work or may not work, right? Like it may not work all the time. But who has already trained on the medical terms, so he will be understands his maybe like a 2 to 3 days his overall routine, and based on that he will be able to give the exact remedy for that disease that he will be facing for that, right? So you should always choose those models that are trained for that particular use cases. So that is how you will be able to get an best of the model that you will be using for. Okay. And the core principle of here is that we will be using the distance, right? Like for example, in the previous slide, we have seen dog and puppy are pretty much closer comparing to the technology or the computer that we were using, right? Like if 2 points are pretty much close in the dimension space, means they are pretty much closer, or pretty much provides the pretty much same meaning, and related to one particular thing only. Okay. And what is the best part is that like it handles the analogy, right? So for example, if the meaning is like a king, okay, king means he's a man, right? So if we remove man and if we add a woman, right, that becomes the queen. So this is how it will be overall creates the example, or the overall do the mathematical relationship between two words, and based on that it will be giving us the result. Okay. So it will be not using any hard coded dictionary based comparison in order to get you the result. So it will be using this kind of analogy and this kind of mathematical relationship between those two words, and based on that you will be getting the overall results. So when I say I guess like we have discussed the same thing, like okay, so here are the some of the models that are available in the market, like an OpenAI or the Hugging Face or the Cohere or the Voyage AI. So Voyage AI is the company that the MongoDB has acquired around like 2 years ago. So they are also into the industry standard, like for the data to embedding model, and it's very much above the par of the industry standard. So these are pretty much provides you the same thing, right? Like each of the embedding model will takes the input and creates the vector embedding and provide you the vector embedding as an output. Okay. So in order to choose the proper model for your application, you should understand your application need. If your application is based on like maybe medical medicine analysis, or maybe if then you should use those model that are trained on the medicines. Okay. So if you are using something like an related to the law, okay, so your model should be trained on the law. Okay. And if it is related to the academics, then it should be trained on the academic related those tokens, like if it has been trained on, so only those models you should be taking and you should be using that. Okay. And you need to be like you cannot use something like a general purpose model for building specialized for certain application, because that might or might not give you the exact results. So you should always use the better model depending on the use cases that you will be using. For example, I have already given, like I studied engineering, I can provide the suggestion for the coding, but I may not able to provide the suggestion for building an building, or maybe like a bridge or anything, because they are also engineer, but they are specialized in something else. Okay, so that is how you will be using the selecting the model that you will be creating for. So when I say the dog and puppy are closed together, right? Like that means like in the high dimensional space, so they have been placed together. How we will be finding the distance between those two objects? Because there are like a huge number of dimensions arrays, right? Because if it is an one-to-one matching, 0.45 is pretty much close to the 0.48, okay, comparing to the 0.54, right? So these two are pretty much close, so it is an one-to-one comparison. But dog will be having something like in 1536 objects, right? Like the 1536 elements, and puppy will be also having the 1536 elements. So comparing both of that is not as much as easy in the how we will be comparing one to one. So for that we will be using different pretty much mechanism. That's what we call it as a k nearest neighbors. Okay, so we take the query and convert it into the vector, and then we will be asking like which is the point that nearest to that geographically closest to the query point that we will be using. So combining all of the array point, it will be having an location in the high dimension space, right? The same way, the puppy will be also having the pretty much point in the high dimension space. So these two will be having a pretty much like the comparatively, if it is closer, then only it will be able to display you the results. Okay, so it relies on the distance between those two particular metrics, and then it will be able to give you the what is the closest points for your query, and that's how it will be giving you the results. Okay, so in order to find this distance, right, we will be having several other mechanism. One is the cosine similarity. That means how much angular difference between point A to point B. Okay, so if it is pretty much closer comparing to the like let's say if it is 0.3 degree of the distance between, like that's what we call it as a theta, right? So the theta is less than a certain amount, then we will be comparing that and we will be understanding, okay, so this is the closest answer to that, and that's how like we will be retrieving the results. Whereas a Euclidean is depending on how much distance between point A to point B is in the scalar method, like okay, in the centimeter or the millimeter, how much difference is there for one points to the other points in the high dimension space. Okay, whereas the dot product is the comparison of both magnitude as well as the angle of the 2 points differences. Okay, so that is how we will be evaluating. And as we know, like the Amazon uses the dot product in order to weigh, like let's say if I am searching for something like a cotton t-shirts. Okay, so it should understand, it should provide the cotton value, and that contain the t-shirt terms also, so that like the user will be picking that. Like it cannot give me the t-shirt with a polyester, or it cannot give me the t-shirt with the other material than the word that we will be using for. Okay, so here one more thing that comes into mind. So when we are passing the query, we are not passing with one simple word, right? Like let's say if I am searching for cotton t-shirt, so here we have two different word. One is the cotton and another one is the t-shirt, right? So for these cotton, it will be having completely different set of what do you say arrays, whereas the t-shirt will be also having the different set of vector embeddings. Okay, so combining these two, okay, then we will be getting one particular vector embedding. For that we have to make the matches. Like let's say x-axis may be matched with the t-shirt or the wearable kind of thing. In the wearable, like you will be even have the watch, even have like maybe the spectacles, because those all are the variables, right? But maybe in the dimension 10 or dimension 11 you will be getting the or maybe finding the similarity or finding the relation about okay, you will be wearing something like a top, okay, and it is related to the cotton, or it is made of fabric or something like that. Okay, so those are the different comparison that you will be getting. Based on that, it will be creating the overall embeddings for us, and for that we will be making the comparison. Okay, so that is how we will be using to get those particular data of that. Okay, and when it comes to the complexity of this k nearest neighbor algorithm, right? So as the matches or maybe the number of document that matches to that particular query, if it is huge, then your query will be start performing slow. Like let's say if it may be better for the number of document or the number of comparison is like 100 or 1000 or 10,000. But if it is like a millions of records, right? Like let's say Amazon has millions of products listed in their website. Okay, so in order to in those situation, if it is finding the exact or the nearest neighbor for that particular product that we will be searching, it will start giving us the bottleneck, or it will be start giving us the because it cannot do the one-to-one matching of each of the embedding, right? Because that may not gives us the better results in the faster way. Okay, so in order to avoid that, we come up with another solution, that is what we call approximate nearest neighbor. Okay, so here what we will be doing is we will be not doing an exact one-to-one matching for the dimensions that we will be finding for. We are giving an like we are trading off the negligible amount of precision in order to gain speed or to get the results faster way. Okay, so the results that we will be getting may not be 100% perfect match. It can even match if it is like if you are finding with the exact keyword, but 99% of the application will be get a huge number of speed comparing to the previous algorithm that we will be using for, and that will be overall winning for the applications that you will be using. Okay, in the example also you can see like we will be having different cluster, and it will be able to find highly dense the cluster like where you will be using for, and that's how you will be getting an exact word overall for the word that you will be searching. Okay, and this is the common algorithm that we will be using. So HSNW is, you can think like an outer ring road. Okay, assume you are traveling from city A to city B, whereas you have to cross 4-5 other districts as well. Okay, so assume like you are traveling from Mumbai to Delhi over the road, not over the, what do you say, like a flight or something. So assume you are traveling from Mumbai to Delhi, so there will be a highway, right? So in the highway, whenever you are passing, you are crossing almost all the cities in between. Okay, but if you want to go any of the nearest city near to the Delhi, means you will take a like you will be not still continue in the highway, you will take a left turn just before that particular city has been comes. So you will bypass that, and then you will be enter into that particular city, rather than going going on the every city that you will be rounding for. Okay, so it is something like an long jump that you will be taking by skipping all the smaller comparison. So here what it will be doing is, like let's say if it is a dog, and then we have something like an adoption. Okay, so those two are not exactly the nearest one, but it can be find in the pretty much closer, because anybody has to adopt the dog only. Okay, so in that cases what will happen is like it will be skipping the animal embeddings, and then it will be skipping the human embeddings, and then it will be finding the related to the adoption embeddings way, and then it will be find the closest one, and then that's how it will be able to matches different level, and based on that it will be giving us the final result. So that's it's in the data structure we call it as a skip list. Okay, so it uses the skip list mechanism, and then it will be able to find the overall, like let's say if it is L0 N21, okay, in the level 0, what do you say, in the level 0, if it is related to the we have to find N21 to the P41. Okay, so what it will be doing is like if it will be have to find the shortest path, or maybe do the one-to-one matching for all the around surrounding keywords, and finally able to get that result. But instead of that, like if it is skip list, what it will be doing is like from L0 to L2 it will be directly going, and from the L2 it will be go to the P42, and then it will be like the illustration is not exactly the same way of what I'm telling, but the overall time I will say, like for take an example for the outer ring road as well. Like let's say if I have to go to the Bengaluru one area to another area, if I use the regular way, it will be takes me lot of time in order to pass the traffic and pass the smaller area and everything. Instead of that, I use the nice road or maybe the outer ring road. It will be bypasses all those area, and I will be able to reach that particular area in the faster way. Of course, like there will be a cost implication that comes into the matter. So that is but it increases the overall speed of the application. So if the speed is my overall concern, I will be using the outer ring road. If the time is my concern, that means like okay, I'm okay to trade off with a time, or I will be waiting for that I can okay to wait the time. In that case, like I can use the old regular method only. So but in today's world, the speed is the most essential, because when you're ordered food, it should give you the tracking in the live manner. But if you send a courier in the DTDC or a professional, so not exactly minute to minute update you wanted, right? Like the city to city, once the city is passed, or maybe like a one station to another station, if the parcel has been passed, then only it will be giving us the updates of that. So this is completely depending on the application basis. But when it is related to the speed, right, we will be using the HSNW algorithm in order to get the better results of for your query. Okay, and one thing that the MongoDB Atlas bypasses all of the other search related databases is that the MongoDB stores the vector embedding as well as the data in the same cluster, or it resides together. Okay, so you already have a databases for your application data that is running maybe since the years of time, and you don't have to sync it to the elsewhere in order to add a search layer to your application. Okay, it uses the like it stores the vector alongside your operation document itself, and it will be the one particular database that your application has to visit in order to comparing the vector embedding as well as to fetch the data that your data that you will be requesting for. Okay, so this is how the MongoDB Atlas will be helpful for that. Okay, and in order to find the result, that means so far I have told if I search for the word called puppy, okay, so it should find maybe like a dog, or it should maybe it can even find the word puppy as well, or something related to the like a domestic, or something related to the adoption, or those are the related keyword. Okay, so how it will be using is like you don't have to build another set of layer on your application. No, not needed. So because the MongoDB query language, that's what we call it as an aggregation pipeline. Okay, so in the aggregation pipeline itself, we will be having the vector search pipeline. In that vector search, you will be passing those particular embedding that you are looking for. For in this particular example, let's say if I pass the embedding for the puppy, right? So it will, how we will be generating this embedding with the help of any of the external embedding models. Okay, so we will be in our application, take an example. It is a web page. In the web page, you have a search bar. Okay, in the search bar, you have entered word called puppy. Okay, and you hit the search button. So what will happen in the background is that keyword that you have entered will be passed to the embedding model, and the embedding model will return me the complete embeddings, vector embeddings. Okay, array of the multiple embedding. This embedding you will be passing then to the databases. Okay, the MongoDB databases for your vector search. You are not passing the dog exactly here. Okay, in the query vector, you can see you are not passing the exactly dog, but you are passing the embedding of those particular word that you are finding for. Okay, so when you pass that, it will be able to make the comparison from the MongoDB itself, instead of you to write any separate architecture for the comparison or anything as such. All you have to do is you have to create the vector index for your application. Okay, so here is a simple example of how you will be using, or how you will be creating the vector search index. Okay, you might have understood regular indexes, right? Like it will be using the B-tree indexes, something like a phone number and a person name. So for the person name, let's say if it is a phone number, it will be using the binary tree. So it will be take the mean number, and in that if the number is less than the mean number, then it will pass to the left side, and if it is greater, then it will be passed to the right side. So like that it will be creating the tree, right? Like the binary tree it will be creating, and whenever you are finding that particular phone number, it will be traversing directly in what order that you will be passing, in what order it has been tree has been generated. So based on that, it will be finding the particular phone number and the document ID, right? So the document ID will be fetched from the storage, and it gives us whose phone number is this particular phone number that you have passed. Okay, so this is a simple index that we will be using in order to find the keyword matches, or maybe in order to find the pretty much one-to-one comparison for your application. But when it comes to the vector search, you cannot use the same index. We have to define vector index only in the pretty much this manner. Okay, so if I have to explain the individual terms here, what we are doing is like we are dynamically mapping particular fields only. Okay, so if I specify dynamic as false, means all the fields in your document will be created as the vector embeddings. That means like all the fields that are there in your document will be passed to the embedding model, and then you will be having those embeddings that has been created for the each value of your field. Okay, but here what we'll be doing is like we are creating a vector index for the field called plot embedding only. Okay, so the plot embedding will be having the array dimension, and it is something like a 1536 dimension. So that's pretty much huge comparison. 1536 is like the number of dimensions that you will be having, and it is using the KNN vector, not the ANN type of value, because it may be okay. So the difference between KNN and ANN is that the KNN will be pretty much more accurate but pretty much slow, because it has to find the nearest neighbor. whereas the ANN is the approximation of your value. It will be pretty much faster, but it may not give you the exact result, right? Like it's something like let's say if I want to find let's say if I ask where is Taj Mahal is located, it will say Agra, right? So that is the approximation. Like it is not an approximation, but let's say if I ask the KNN where is the Taj Mahal is located, it will be giving me the exact latitude and longitude, maybe like a exact district or exact the local area name as well. So that is how the KNN will be working, whereas the ANN will be giving the faster result comparing to the by trading the speed for your query results. Okay, and then the similarity has been cosine. So this is based on the angular distance. Here we are not using any of the dot product, or here we are not using the apart from the cosine, like Euclidean, any of the other similarity, but we are using the cosine similarity. That means we are finding the distance depending on the angular distance between the 2 points, whereas for other products, like for other similarities, we will be using different mechanism. So this is how we will be creating the dimension space. Okay, so now we have the dimension space that has been created. Our point has been located for each of the term. Okay, so in order to generate this plot embedding, right, what we have to do is, like, let's say we already have the data existing in our databases. We have to run the update operation, and in that, for any of the plots, like for example, let's say I have the IMDb databases. Okay, so in the IMDb database, it's completely about movies, right? In the movies, I will be having title, I will be having uh, director name and casting, and my bad. Yeah, so I will be having casting, I will be having director name, and I will be having the description about the movie, and I will be also having what are the awards that it has won, like that. So I will be having all of the data about one particular movie. It is mentioned in the document. Okay, so what I will be doing is I will be creating the for the description, I am creating the vector embedding. Okay, so where this vector search will be most useful is that think of like an not as an one-to-one comparison, right? So if it is an complete description about the movie, right, because the same director can be directed multiple movies. Like if you are searching for something like an Rajkumar Irani's movies, right, like it can even show like a Three Idiots or like lot of other movies as well. So one may be super hit and one may be utter flop as well, right? So if I think in that way, Rajkumar Irani's movie, all the movies will be great, and I will be ended up watching the movie which I don't like. Okay, so it can be that kind of results as well. But in order to avoid that, what I'll be doing is I will be creating the for the description, we will be creating the embedding, because the description is multiple lines of paragraph, and multiple paragraph will be there. So for that, it will be creates the embedding, and that embedding we will be storing in the plot embedding column. Okay, so when the user search for the something like an like the college students movie with an emotions. Okay, so what it will be doing is, in the description we will be having three college students from the different area of the, so from the different part of the country, understand the value of the friendship and grows differently in their life. So this is how the description is of the movie has been written, and in that case it will be having the words that you will be finding similarity matches with. Okay, because I am trying to find friendship movie of the college students. Okay, in the description it is having pretty much similar meaning, whereas the word I am searching and the word that are there in the description is completely unrelated, like those are not pretty much same at all. So in those cases, it will match with the help of the high dimension, with the help of the embedding, and then it will be giving us the results that can even match, like maybe Dil Chahta Hai, or maybe something like Three Idiots. Like these are the movies that can even matches here, or maybe even the Rang De Basanti as well. Like these are the movies that it will able to match, and then it will be gives us the results. Okay, so this is how the Atlas search index that you have to create, and based on that you will be able to fetch the your overall results. Okay, and as I said, in some of the cases, like we will be using the vector search, right? Like let's say if it is a huge description, in that, like if I want to find particular one or two words, if I know, or maybe like a movie that I remembered I watched some 4 or 5 years back. I don't remember the exact name of that particular name of the movie, but I know the liner of that movie. In those cases, vector search will be useful. But let's say if I want to search for the one-to-one keyword example, like let's say Rajkumari Rani movie, or maybe like Amir Khan casted movie, like that's also comes like a lot of other example. But let's say if I know the exact word of the title, right? Like let's say Rang De Basanti. Okay, so if I use Rang De Basanti in the search bar, and if it is using the vector search, it is huge loss or huge waste of your resources. Okay, so because it is a one-to-one match, because it don't have to take the exact word, because some of the movies title will not match with the what actual data it will be having. Some of the movies will be having hero's name. Okay, one of the movies is that something like an Maurya. Like let's say take an example of Maurya. Okay, so that is the one of the movie, and in that Maurya, if it is finding an comparison, right? So it might think, okay, okay. So take an example of Ashoka. Okay, so Ashoka will be emperor, or if it is trying to fetch the movie, it can even give you the results of Ashoka as well. But there are other movies also that is related to the Ashoka. Okay, something, because Ashoka is related to the Buddhism, or Ashoka is related to the Kalinga War, or Ashoka is an emperor. So all other emperor movies also it can even show you. So that may not be an exact or ideal match for results for your query that you will be searching for. Okay, so in order to avoid that, what we will be doing is, like we will be using something called an hybrid search. So hybrid search is a mechanism where it will be using both keyword search as well as the vector search. Okay, and it literally puts both the search in the race. Okay, it literally says, on your mark, get set, go, and whichever the results or whichever the terms that gets the results, it will be gives us those particular results back to the application. Okay, so the lexial search is something like for the exact keyword search that you will be looking for, and the vector search you can use in terms of like a in terms of like finding the meaning, or finding the combination or the content awareness of that particular words that you will be searching for. Okay, so based on this, we can even write a hybrid query. That's what we call it as a rank fusion. So based on the rank that each of the search result will be fetching for, those result set will be displayed by the MongoDB. Okay, and you can even set like how much size of the result. Like let's say if you mention like a 10 size, so 10 records that will be matched, and those 10 records will be retrieved, and it will be able to give you the result. Like some of the results may be fetched from the keyword search that has the better ranking, 0.89 or 0.9, or like 1.0 is pretty much rare, because you might be having a missing in terms of like a comma or semicolon or something like that. So that is how it will be able to match those results. And some of the results maybe you might have got from the vector search as well. Okay, so based on that, it will gives the whatever the size that you have mentioned. So for that amount of data, it will retrieve and it will be give you the overall results. Okay, so this is the one of the advantage of the hybrid search that we will be using. Okay. And in the MongoDB, in the production environment, what will happen is all these backend, what do you say, like the processes will be running on the same data where it is resides, right? So that can eat up some of the resources, and the actual data insertion or the data retrieval overall process can be like the reserved resource for those particular actions will be facing an issue. Okay, so in order to avoid that, we will be having dedicated or an isolated search node where all these search related process will be run in those particular machines, and you will be not hamper your production data nodes for any of its day-to-day regular activities as well, because the search is one of the feature for your application, whereas your application will be frequently reaching the database nodes for varieties of other retrieval or maybe insertion or maybe like updation of so many things. Okay, so in those cases, like it will be frequently visiting the databases. If the database is busy with the previously user searched query, and it will be not able to respond to the new query that has been come from the application, so it will makes the entire database as a slow, so it will not able to get you the better results. So in order to avoid that, we completely isolate the search and the data node completely differently, so that like you will be able to get the better performance in the overall. Of course, like this as comes with the additional cost and everything. Okay, and then actual topic of the day is like a like how we will be building the like so far what we have explained is completely the what do you say, the foundational. Okay, so why and where and what are the things that backend how it will be working. And in order to answer your today's session, so we will be using the RAG, right? So RAG is a retrieval augmented generation. So in that, what we will be doing is the LLM can hallucinate, right? Because it has been trained on the certain models, and maybe the model has been trained maybe few days ago. So whatever the data that you are asking may be related to the related to today's data, so it may not able to give you the results, right? I've had some issue with the keyboard, I guess. In order to avoid that, like we will be using LLMs in order to get you the overall results. Okay, but by using the vector search, you giving an LLM for using the vector search, what we'll be doing is like we are giving the LLM an open book test kind of thing. Okay, so the LLM, if it is not know the answer, it can directly go and fetch from the LLM, and then it will be able to retrieve the answer. So how this will work in a regular or the simplified way is that, let's say you are searching in the databases for something like retrieve me last month sales report. Okay, the LLM understood that I have to write a query. Okay, I have to write a database query. Okay, related to the sales. That means I have to find something in the sales table. Okay, so in order to get the sales result or the sales report, I should be know what is the sales that has happened, what is the revenue, what is the profit or loss, and that's what it should be generating for month on month basis. Okay, March how much, April, May, June, like July, something like that. So based on that, it has to generate the overall graph for you. Okay, so this is the thing that it has understood now. So for this, it has to write a query. Okay, so in order to do that query, so the LLM can access the queries depending on your specific table relationship. And in that table relationship, like it will be, okay, maybe finding the particular sales collection. In that, what is the name of the sales data, and what is the name of the profit or the loss field, and what is the name of the revenue field, and what is the tax, and all this data it will be having by the LLM, because the LLM is not hallucinating now. It is referring to your databases. In that, it is fetching those records. Okay, so it will be use those data as an open book, and it will then generate the query and then execute that query on your behalf, and then finally generates the reports, and then it will be able to give you the overall results. Okay, so this is something like the any of the databases that you can use, but the RAG will be utilizing the databases for its own references or anything as such. Okay, so here the MongoDB will be used as a memory for your AI application. Okay. Okay, so whenever the user is doing the chat bot. Okay, so let's say you are building a chat bot and you have requested in the Amazon chatbot, what is the order status of my previous order. Okay, so now it know your user ID. For that user ID, it will fetch all those orders, okay, that you have made. In that orders, it will be generating what is the latest order and order number. Okay, so then it will also ask you like what is the order that you are referring to. Let's say there are 3 to 4 orders that has been not delivered, so then it will ask you like which is the order that you are referring to. You can select whatever the order that you are interested for. So for that order, it will pick the order number, and then that order number will be maybe having the tracking number or anything as such. For that, again, like it will be do the API call and gets the exact tracking location of your record, and then it will be gives us the results. Okay, so that is how the RAG will be overall using your MongoDB databases or any of the databases in order to retrieve the logic of the retrieve the data that your user is requesting for. Okay, so if your AI agent is like forget, like let's say whenever you are doing the chat and you like maybe network issue, or maybe like there is a disruption that has happened, and you will be come back again after maybe like a 2 days or 3 days. Okay, still I have not received my order or something like that with that particular question. What the AI agent will have to do is it will be saving your previous chat conversation in the MongoDB in the flexible model. Okay, because the MongoDB provides the flexibility of using your overall data and flexibility. So based on that, like it will be using the chat ID for that is a combination of maybe like a user ID and maybe like a order ID. So depending on what is the session that it has generated. So for that, like it can store those data into the databases, and whenever you come back and ask for what is the update of my previous question. Okay, so then it will go and fetch those data and retrieve that, and then again come back to the databases, like what is the latest update of current status of your data or where it is locating. So based on that, like it will retrieve the data and it will be able to get you the results. Okay, so that is a simple use case, and it will no need to build an if else statement kind of routes, because whatever the intent that the user will be passing, right, based on the query vector, so it will be routes to the exact ticket that automatically, and it is like a pretty much easier and cleaner for maintainability, and it will be also handles pretty much how the overall confusions that has been generated. Maybe like if it is an if-else statement, you will have to you cannot give or generate an application that can allow the users to enter the query. Okay, so you will have to give an option. So what you have to do today, raise a ticket or track my previous order, like that you have to give an option. So based on that, like, it will be able to get you the results. But let's say as an user, that may not give me the better or an trusted feeling if I'm using that particular application. So it should be able to allow me to write whatever I am there in my mind, rather than selecting only those options that are available in the in the application, right? So in order to overcome that, it will be using the RAG, and it will be using the LLM. The LLM again like lies back and uses the databases, and then it will be giving us the better human relationship, and that will be avoid lot of the confusions that the user will be having. Okay, and vectors are like, like it uses huge amount of data, whether it is an text, or whether it is an audio clip or an image. The model will turn then all into something like an huge vector space. That's how like a platform like Pinterest, or even the Flipkart, or even the Google Lens uses the image search as well. So based on that, like, it will be generating your overall vector into the overall data into the vectors, and based on that, it will be giving us the results. Okay, and when we are using huge number of let's say a paragraph, or assume like you are passing something like a PDF of like 50 pages, 100 pages, or 300, 400, thousands of pages PDF. Okay, so in that case, the paragraph 1 and paragraph 135 completely unrelated, right? In order to avoid that, you should ensure there is a and if you are passing the entire paragraph, or like 3000 pages into the databases, it cannot directly convert them into the embeddings, because that will be completely not having any of the relationship at all. In order to avoid that, you have to chunk your your data into multiple parts, and make sure each of the chunks is overlapping. Okay, so here you can see the chunk 1 and chunk 2 has a little overlapping, and chunk 2 and chunk 3 will be having little overlapping, so that you will be having comparison, and you will be having the connectivity between one paragraph to another paragraph, so that you will be able to logically get those results in the faster manner. Okay, then in that case, you will still have the some meaningful comparison from the paragraph 1 to the paragraph 135, if there is a something overlapping chunk between those two particular paragraph. So without that, you will be not have any of the comparison. So if you are searching for the replication, and the first part of the textbook, or the first part of okay, for example, take an example of second PUC chemistry book. Okay, so in the second PUC chemistry book, like the maybe the last part is something related to the industrial chemistry, whereas the first part is something related to the general chemistry. Okay, so if you are searching for the industrial chemistry from this particular PDF, it might not give you the results, because the first paragraph is not related to that particular value at all. And this entire textbook has to be chunked in such a way that whenever the any of the high dimensions that has been created, it should able to understand that, okay, so it is also related to the industrial chemistry as well as the general chemistry, whatsoever the complete book content is all about. Okay, so based on that, it will be able to retrieve the results in a pretty faster manner. Okay, and yeah, so model incompatibility, so this is the same thing. You cannot use the one model for creating the embedding and another model for querying the embedding. Okay, so you should, like, let's say if you have used OpenAI model for creating the embedding from the data, so you should use the same embedding model in order to retrieve the data. It is something like, let's say I have written a novel in maybe like Kannada. Okay, so only those who can read the Kannada can able to understand what I have written. Okay, so this is the same thing when you are creating the embedding using certain model. Okay, so you should use the same model in order to retrieve the data. So it is pretty much same in even in the encryption decryption also you should use the same key, right? Same way here also you should use the same model in order to maintain, or in order to get the, not get the exact result, but in order to get the result you have to use the same model. You cannot use the mix match different models altogether. Okay, and in the production reality, optimize for the latency and the cache use for frequently searching terms, and that will saves overall vector search cost. That means, like, let's say if the query is frequently using, in those cases, like, you should use the caching mechanism in order to retrieve those data. Okay, and it will be better always do the pretty much filtering mechanism in order to relate it to, like, let's say if it is a t-shirt, then retrieve or the filter using the men version or the female version or unisex, like that. So you should filterize your data so that the number of data that you are retrieving will be pretty much narrowed, and you will be getting the pretty much better results. Okay, so when you are retrieving those data. And for your AI application, once you have the production in your hand, right, like, you should always optimize for by applying the better metadata, or better schema modeling for the MongoDB. And then with the help of the RAG application, sorry, with the help of the RAG, you will be able to retrieve those data, and by giving them the better results, or giving them the better enhanced open book kind of overall the MongoDB's status to that, or database status to that, so that, like, it will be able to retrieve your overall data pretty much better way comparing to the any other regular search kind of mechanism. Okay, so yeah, so this is the vector search assessment that you can take. Like, just scan this particular QR code so that, like, you will be able to take this record. Ajay, would you like to take over from here?
Yes, yes. So, yeah, Ajay, thanks, Darshan. I'll just quickly tell. So, see, guys, so on this screen, you would see this particular link. So, you will get an access to a test. Okay. If you are unable to scan this QR code, Mr. Ajay has shared a link as well. So you will see that there will be a quiz. If you complete the quiz, you will get a particular MongoDB skill badge, which is the official MongoDB skill badge. And we'll give you around 7 to 10 minutes to complete it, right? So please, everyone, please take the assessment so that you can get the MongoDB official skill badge, right? If you are unable to scan the QR code, Mr. Ajay has already shared uh, the official link in the chat. You can click that link as well and take the quiz. Once done, please update in chat that you have done and received the badges. And if you have not received the badge, please let us know that as well. Okay. And Mr. Darshan, like before, let them take the text, the particular assessment, right? So just let us wait for 5 to 7 minutes, right? So that they can take the test, and I'll just close with some remarks. Will that
Sure.
be okay? Yeah.
Yeah, totally fine. Yeah.
Okay. Thank you so much. Please, everyone who is in the session, once you have done the assessment, once you have received the skill badge, please let us know in the chat. You can write done. Okay, done. You can update by writing done in the chat.
So there will be a 10 questions and
Yes,
it will
there will be
be
10 questions. Yes, sir. There will be 10 questions and getting 404 page. Okay, let me just check quickly.
the 404 is for QR code or the URL. If you can.
Let me just check. For URL, just try to scan Karthik. If the URL for URL, I think you have to uh, just try to open it in incognito. Karthik, open the link in incognito, right? Probably it will ask you to register or log in MongoDB University.
No, no, it
Okay,
is
miss.
you just have to enter the email. That's it. You don't have to log in. You have to write an email. For that email only, you will be receiving the Credly badge.
Correct, correct. So Ajay has given the updated link. Yeah. Okay, thanks. Thank you, Ajay. Yes, mostly it will be like you just have to write the email and directly you will get the quiz access.
Correct.
So if you Oscar has done, cool. What about others? Please update why done here. We'll give you like 4 minutes more, 5 minutes more you can take. Shravya, you can start. Shravya, you can start the assessment. You just start the assessment and complete it. Just there are only 10 questions. Once done, you will receive the badge. Do not wait for us, guys. You just click on the link or scan the QR code, write your email, complete the quiz, and done. Okay, good, Ashwat. Good. Good, Shantanu. Good to know. Please update it in the chat, not in the Q&A section, guys. Please, if done, update it in chat. Company name. Okay, company name you can write NA or you can write your college name if you are in college. Good to know, Mayank. Nice, Bhavesh and Ganesh. Cool, Sanjay. 2-3 minutes more, guys. Please update here if it is done. Anuranjan, cool. Hemant, nice. Excuse me. Thanks, Tarun Kumar. Thanks, Abhishek. Okay, cool, others. Nice. Thank you, Ganesh, for attending this wonderful session as well. Right. Uh, Done. Right. So just wait. Uh, just wait. I'll just quickly add some remarks and certificate others. You will get a skill badge, right? And once you got the so once you get the skill badge, as you can see on Mr. Darshan's screen, you will get a Credly skill badge. Okay, so you can see all the steps. Once you get the badge, you have to mention the SmartBridge and MongoDB. Okay, you have to mention that. Ajay, please could you like write the SmartBridge and MongoDB message that they have to mention it in their LinkedIn. So once you share in on the LinkedIn, right? Once you share your Credly badge, you have to mention, right, the SmartBridge, and you also have to tag MongoDB as well. Official MongoDB LinkedIn account. You have to mention that. You can also use the hashtags. Hashtags are must. You have to use both MongoDB official hashtags and the SmartBridge hashtag. Okay, which you can see on the screen. So just 1 minute more, right? And please make sure that once you receive the badge, you share it on LinkedIn with these hashtags as well. You can take the screenshot if you want for the hashtags. Okay. Once you share on the LinkedIn, you can take a screenshot of this if you want to use these hashtags. These hashtags are must, which is MongoDB and the SmartBridge. You have to tag both of these accounts when you would be sharing this skill badge. Okay. So just 1 minute more, and then I'll just share my screen. Yeah, you Darshan, please whatever you have, please say. Then I'll share.
Yeah, so this is yeah. So we came to an end of seminar, and thanks for being attentive. I have seen like some of the questions, but I believe like I have answered pretty much everything. But if there is anything, I don't know whether we have a time or not to answer some of it. Uh,
Uh,
Somebody has
you
asked
can go
about.
ahead if you want to.
Yeah,
Yes,
somebody
yes.
has asked like what is the limit of the chunk. So there are no such chunk limitation. It is something like like you have to do the logical chunking based on the file that you will be passing with, because if it is like a too broad prospect, or the broad kind of words that it is there, in that cases like it has to analyze all of them. You will be having lesser number of documents, or the lesser number of character. And if it is like a pretty much related to the one word to the other word, then in that cases like you can increase the number of characters as well. So it is something like a logical chunking, not like an physical chunking of your record. So that is completely application specific. There are no hard core end or rule for in order to handle that particular question actually. So it is completely depending on the application use cases. And somebody has asked how do we handle these databases actually to recognize the analogy. It has been asked by the Zainab. So how do we handle these databases? I am not pretty much sure like in what context you are asking. Like the handling the database, the MongoDB Atlas is completely managed by the MongoDB itself. Like you just have to get the connection string and start using the databases. But in order to actually recognize the analogy is maybe you are relating to the terms or the data that you are passing, I believe. For that only, like we will be using the transformer models, like any of the LLM models. The LLM models will be understanding the analogy and it will be understanding the overall context of your data. And based on that, like it will be giving us the final embeddings for us. So using that embedding, like we will be like not we like the MongoDB will be generating the high dimensional space for that particular data, and it will be giving us the retrieval methodology depending on the query that you will be using for. And what is the embedding done on, and the tokenization method, word tokens for sub tokens will be used. So the what is the embedding will be done on? So embedding will be done on the data or any of the field in the MongoDB document that you will be having, right? Like for example, of the movie document that we have taken, the description or the how the like the movie one liner. So for that, like we will be using. So that's what, like when you are using the vector search, use it for the like the complex search rather than one-to-one searching. If you are using, it will be not makes any sense. It will drain your resources. In order to avoid that, use it for the complex search and a context awareness search if you are using. So in those cases, like it will be helpful. If you are not using that, like if you are using the one-to-one search, in those cases, like it will be not helpful. Like even though you can get the result, but it may not be that much effective. For that, you have to go with the previous like the keyword search mechanism only. Okay. And tokenization method and the word token and the sub token, it is all these will be handled by the like the while you are creating the index itself. Like you can specify that the tokens and the sub tokens will not be comes in the vector search, because we are passing the entire data all together to the LLM, and using that, like it will be handling. So the token tuning or optimization of the token that comes, that may not be possible, because we will be having thousands of document, and each of the document will be having different data altogether. For each of the data, we may not able to exactly convert them, or the optimize the token utilization for converting that into the embedding. That will not possible in the real world at all. So in order to, that has to be bear by the user itself, like whoever is building the data. So if they are, while inserting itself, like if they can tokenize it, or maybe like maybe use the optimized data for that particular field, in those cases, like it will be pretty much like uses the optimized way of your overall LLM billings as well. Okay. Yes, that's it. Yeah, I guess that's it.
Yes, I think only three or four questions are there, and you have covered most of them in your session as well. So yeah, I'll just quickly share my screen, right? So
Yeah.
I'll just share my screen and some closing remarks on my side. Just a second. I hope my screen is visible, right? Yeah. So thank you so much, Mr. Darshan, for such an insightful and engaging session. And I'm sure every participant who is here, like, gained as much clearer understanding of MongoDB Atlas Vector Search, and how it supports intelligent AI applications, and how these concepts can be like work in our real world use cases. And A heartfelt thank you to all of our participants for joining us today, right? And for actively engaging throughout the session, right? And we truly appreciate your time and enthusiasm for learning. It is a Saturday, of course, and then also you all were very enthusiastic, and we hope that today's session has added valuable knowledge to your AI and technological learning journey. And before we close, like I have some more things that I would like to tell you. So you can explore our website, our organization's website, the smartbridge.com. Okay. You can just go www.thesmartbridge.com. Like Ajay would be adding the link, right? www.thesmartbridge.com. You can just explore the website. Okay. That is number one. So any courses, anything that you would like to inquire about, right? Whether it is any opportunities or any learnings, right? And you want your college or anyone to be a part of us. Uh, but definitely please hit that URL. Okay. And there is another one which is where it is. Why is it not? Okay. The another one is virtual internship program. Okay. So virtual internship program is one of our initiatives of SmartBridge. It comes under My Skill Wallet, which is our own in-house product. And if you want to explore more, please check out this website. Okay, the links I'll be sharing it. Okay, in the chat. So the link. Or Ajay, I think you can just share this particular link, right? So these two things, I think everyone is clear. You can just go to our website to explore more, and you can also look into our virtual internship program. Okay. So coming back to this, I'll just quickly before we wrap up. So, a few ways you can continue your learning journey with SmartBridge. Check out these URL and check out these scanners and QR code. Don't forget to follow SmartBridge on LinkedIn, Instagram. We have our YouTube channel as well and other social media channels to stay updated on any upcoming webinars. Like we have Mr. Darshan here. We'll be having more such industry experts and we'll be having more upcoming webinars, expert led sessions, virtual internships, of course, which I mentioned previously, and certification programs and focusing or career focused learning opportunities. And we'll also be uploading the recording of today's session on our YouTube channel. So just in case if you or your colleagues or your friends have missed it, you can check the today's session on our official YouTube channel. So make sure you scan all of this and follow us there so that you can see the recording of Mr. Darshan in that particular YouTube channel. Okay, the SmartBridge YouTube channel for which the QR code is there, and you can revisit the session anytime and share it with your peers who may have missed it. Okay. So if you are looking to turn your learning journey in a structured career way, of course, you can look into our skill wallet application. So is this done? Can I get a quick reaction? Are you guys following up with this? Can I get some reaction? Any emoji reaction? Okay, okay. Nice, nice, cool, cool. Yeah. So, again, so if you're looking into like turn your learning into a structured career way and other stuff, you can look into Skill Wallet app by SmartBridge. So download the Skill Wallet app from Google Play Store or App Store and explore role-based skill pathways. Okay, that can help you understand the skills you need for your career and for whatever you are targeting, to be honest. So whether you are into AI, data, cloud, Salesforce, cybersecurity, MongoDB, or any other emerging technologies, Skill Wallet will help you making it easier and discover relevant role-based skill pathways. So which will align, of course, with your whatever career goals you have. Okay. So download Skill Wallet today and start building it. uh, right? And thank you once again for being with us today. And keep learning, keep building, uh, right? And thank you so much, Mr. Darshan Jayarama, for this wonderful session. And hope everyone enjoyed it. And uh, thank you once again, right? If you have any closing words before I close this session.
Uh, First of all, thank you to all the participants who joined and make the event success. And special thanks to the to Mr. Darshan who very explicitly explained about the MongoDB vector search. All the closing statements already given the Etharth. So I just want to thank all the participants, Mr. Darshan, Etharth, and Ajay for hosting the events. Okay, thank you. So Etharth, hope we can conclude the event.
Yes, yes. Thank you, Arshad. Uh, Arshad is the subject matter expert here in for MongoDB in our organization, the SmartBridge. Just for any of the participants who are wondering. So thank you, Arshad. Thank you, Mr. Darshan Jayarama. And
Thank you.
again, thank you. So keep learning, participants, keep building, keep exploring. Please share your LinkedIn. Please share the Credly badges that you got in today's session on your LinkedIn and tag us and MongoDB. Okay, so have a wonderful day, and we look forward to seeing you at the next SmartBit session. So thank you, everyone. And yeah, we can, I think, close this particular call. So I'll just stop sharing my screen.
Yep. Thank you, everyone.
Thank you.